In this video, we're going to add the parametric dimensions to our figure. We're going to start with the linear dimensions. So if we click on the arrow under the linear dimensions, you can see we can add horizontal and vertical separately. But let's just do linear because that's general. All right, so I'm going to hover over the top horizontal line near the place where I want to dimension. So I'm going to dimension really the length of this line, but I want to go from the top horizontal to the bottom horizontal. So I'm going to hover over the top horizontal near the corner where I want to start the dimension, and then the bottom horizontal where I want to end the dimension, and then pull it out and click. So right now it says D1. D1 is the name of the dimension, and it's giving a dimension. It really doesn't matter what the dimension value is because we get to change that. So just hit enter and leave it whatever it is, because we will change that later. And the next we will put in this top one, so the length of this line. So we're going to hover here and here and put that one, and it's just going to name them in sequence. So D2, the next one will be D3. So I'm going to go from this side to the center of the circle. D4, I'm going to measure the length of this line. So from here, do you notice how it went to the center, right? I want it to the end here, to here. And I'm not dimensioning it as a part print. So I'm not conforming to regular dimensioning standards. So this is going to look ugly, right? I'm dimensioning for size in this parametric world. So I'm not using, a datum. I'm not, coming off of a datum per se. It's going to look strange as far as dimensioning for a part print, but that's not what I'm doing. I'm just putting sizes in. All right, so next one, I'm going to get the height of the circle here. All right, so that's all the linear. Next, I'm going to put in an angle. So angle is right here. I'm going to dimension the angle. So angle 1 is the name, and then I'm going to do the diameters. So this is the diameter. I'm going to do the outer one, and then the inner one. And they all have a name. Right, they have a name so that we can identify them. Right, if we want to connect up diameter 1 with diameter 2, we can write a formula between them, and we write a formula using the dimension names. All right, so now we're going to change the dimensions. So let's double click on the angle. So we're going to double click on the angle, and we're going to change that to 45 and then enter. So that's kind of nice, right? You can just draw something. It doesn't have to be the correct value like you're used to, right? In AutoCAD, you usually draw it to the correct size right away. But in the parametric world, you can just draw something that's kind of the right shape, put your geometric constraints on, put your dimensions on, and then change the size later. So we're going to continue to do that with the rest of the dimensions, but instead of putting in a value like 45 degrees for the angle, we're going to connect every single dimension on this drawing to diameter 1. All right, so diameter 2, we're going to make that 2 times diameter 1. So 2, and then the star above the 8 times DIA 1. Oh, do I have them backwards? Yes, I do have them backwards. So the outer one should be diameter . No, this should be the inner one. Let's undo that and go back. All right, so the inner one should be diameter 1. All right, so let's have a lesson on how to change names. So double click. I'm gonna make that diameter 3 just for now. Double click, make that diameter 2. And go back to diameter 3 and make that diameter 1. So right away I knew there was something wrong. All right, so now diameter 2 should be 2 times diameter 1. Much better. All right, so you can see how this FX in the front says that, okay, now diameter 2 is being controlled by a function. All right, so we'll go on to dimension 1. So dimension 1 is going to be 7 times diameter 1. Dimension 2 will be 5 times diameter 1 divided by 2. Dimension 3 will be 5 times diameter 1. Dimension 4, 2 times diameter 1. Dimension 5 is equal to diameter 2, which is indirectly equal to diameter 1. All right, so let's see what happens when we change diameter 1. So let's double click on diameter 1 and put 30 in. And I'm going to tell you up front, something is going to go terribly wrong. There, terribly wrong. So when this happens, don't freak out, right? Because this can happen a lot when you're working with parametric objects. Just do the Control Z and get back to where you were. This is telling you that your object is not completely constrained. And like I said, this happens a lot when you're working on parametric objects. So what is happening is that we don't have all the dimensions on. So when you change a dimension and it changes everything else, it changes everything else except for that thing that's not constrained. And what we're missing is the overall length of this object. So we're going to make this overall length 15 times DAA1. And now if we change diameter 1 to 30, it should work out. It'll get big. Oh, I gotta get out of the text and zoom all. But it will remain the same shape, right? And that's the power of parametric design. So let me change it back to 15 so you can see, right? Same shape, just different size. Change it to 30 again. So if an object is completely constrained with parametric dimensions and geometric constraints, and all the dimensions are linked to like this master dimension, you can do this, and it's very powerful. But like I said, if something is not constrained completely and you change something and it goes like wacko, don't worry. Just undo and try to find out which of the dimensions or which of the features in your object is not constrained.